So our next step now in nomenclature is to put all of this together and see how we use this to come up with the name of an organic molecule. So we're going to come up with a name for the molecule that we have here. And in order to do this, or to name any organic molecule, we have a series of steps that we use to come up with the name. So step one, find what we call the parent alkane. The parent alkane is the longest continuous chain within the molecule. Sometimes I find a good way to think about it is what's the longest chain you can trace in the molecule without lifting your pencil. In some cases it's very obvious. In other cases it's more complicated. But it's not always going to be straight across. So one of the common mistakes I see is that we just look straight across the middle and say there's a 5-carbon chain. And that is a 5-carbon chain, but it's not the longest chain in the molecule. The longest chain in the molecule is this one here. And if you count it, it's a total of 9 carbons. So this means in the end that this chain is 9 carbons, and this molecule is going to somehow be related to nonane. Or nonane is the parent alkane for this molecule. Alright, so that gives us the first piece. What's the next piece? Well, now we number the carbons of the parent chain. And for an alkane, for a straight chain alkane, there's always going to be 2 options. Sort of left to right, which I've done in blue, and right to left, which I'm doing in green. Now before I go any further, you might be wondering, what if there were 2 chains that were both the longest chain? Which one do we pick? And if that were the case, what we would do is we would look at each one of those longest chains and count how many substituents or branch points they had. And the one that had the most branch points would be the one we use. Alright, so now we've got our possible methods for numbering this. So let's look at the blue numbers. Using the blue numbers, where is the first carbon that we have a branch on this molecule? So this first carbon just has hydrogens and the parent chain. Same thing with the second carbon. But carbon 3 has a branch point. The next branch point is at 4, and then there's a substituent or a branch point at 5. What about if we start over here with the green numbers? The first substituent is at 5, the second one is at 6, and the last one is at 7. So how do we pick? Well, we look at the first substituent in either direction. If they're different, we don't have to go any further. If they're the same, we go to the second substituent. If they're the same, we go to the third substituent, and so on. But wherever that first difference is, in this case it's at the very first substituent, we look to see which one is lower. So since 3 is lower than 5, we use the blue numbers. Doesn't matter what the rest of the numbers are. As soon as we find a point of difference, that's what determines the direction that we go. Alright, so we found the parent alkane here, which was nonane. We've defined the correct direction of numbering, which is with these blue numbers starting up in the upper left. Third step, name the substituents. So our first substituent is the one at carbon 3. How many carbons are in that substituent? We should get 1. And we learned previously that a 1 carbon substituent is named methyl. So we have a 3-methyl. On the 4th carbon, we have a 2 carbon substituent, which we know is ethyl. So 4-ethyl. And then on the 5th carbon, we have a 1 carbon substituent. So we have methyl again. Alright. Unfortunately, got to go to a new page because we're running out of room on this slide. But we're going to keep using this information, because the next thing we have to do is combine like substituents. So recall the 3 substituents we had were 3-methyl, 4-ethyl, and 5-methyl. So 2 of those are the same substituent, methyl. So we take our 3-methyl and our 5-methyl and combine them, because we don't need to list the name of a substituent twice if it's the same substituent. So we combine them and we say 3, 5. Now since there's 2 of them, we need to specify that there's 2 of them. So we do that with the prefix di, methyl. So what this is telling us is that we have a methyl substituent. The dimethyl actually tells us we have 2 methyl substituents, and the 3 and the 5 tell us that those 2 methyl groups, one is on carbon 3, one is on carbon 5. What if we had 3 of a substituent? Then we'd call it tri. 4 would be tetra, 5 penta, and so on. Make sure you remember this one, tetra. That's the one I see students get wrong more than any other prefix in nomenclature. Alright, so we are almost done. Now, step 5, alphabetize the substituents. So what comes first? 3,5-dimethyl or for ethyl. When we alphabetize, do not include any numerical prefixes. So dimethyl, if you're alphabetizing that, goes under M, not under D. So finally, write the name. And when you're writing the name, the substituents come first, the parent name comes second. So this molecule, again, ethyl gets alphabetized under E, whereas methyl gets alphabetized under M. So 4-ethyl, 3,5 dimethyl nonane. And if when you're writing this out, a couple of pieces of formatting. In between a number and a name, we always put a hyphen. In between two numbers should be commas. And then between the last substituent and the parent name, no space at all. And these aren't as big a deal when you're taking an exam in my class or something like that. But if you're doing online homework and you accidentally put a space there or you put the wrong punctuation in, the computer is probably going to mark it wrong. So we will continue in the next video with a couple more examples.